Hey everybody, today we're going to work on solving exponential equations. Now, most of this stuff is going to be review, most from last year, but I think it warrants the review. Big focus for today, don't segment your knowledge. Okay, and what I mean by that is let's try to take a look at everything that we encounter today holistically. One strategy to solve everything, as opposed to breaking up numerous strategies to solve each individual problem. By the end of this unit, we're going to have a bunch of stuff all jumbled up together, and you're going to be asked to solve a number of different types of equations. And we want to have as few strategies as possible for us to try to break things down with. The more we can look and go, hey, I got three things I can do and use on everything, as opposed to I need to memorize one strategy for each individual type of equation, our lives are going to be a lot easier with it. So let's jump in and let's take a look at A. A would be a very typical sort of equation for us to solve, and I want you to kind of understand that I recognize that I'm going to be very repetitive today. It's for a reason. I'm not so concerned whether you can solve exponential equations today, tomorrow. I want to think big picture. And so for us to be able to work our way through, it means I'm going to have to recognize a certain situation I'm in, which means I have to ask myself a question that I don't normally have to ask. Take a look at the equation in A. 3 to the exponent, 2x minus 5 equals 27. The question I want to ask myself at the beginning of every single equation I have to solve: where's the variable? Where is the variable? And I notice that that variable's in the exponent, and so that's what drives my motivation. If my variable's in the exponent, I got to get it out. And one way I can do that is to try to write that as a power equal to a power with the same base. And so if we recognize that we can take that right side, 27, and write it as a power base 3 as well, then now that I have a single power equal to a single power, and their bases are the same, therefore their exponents must be equal. Notice that line's going to start with a therefore symbol. I've applied my piece of theory. There is no operation that takes me from my first red line to my second red line. There is no operation. Please don't think, hey, and the bases drop out. No, they don't. That therefore symbol at the beginning of that line tells your reader that you've applied a piece of theory. And that theory is a power equal to a power, the bases are the same, means their exponents must be equal. And then once you show me that line, I don't care whether you want to give me this line or not, because that's just an operation. You go through, get down to your solution, and we should be good. The only lines that I would ever have to see as part of your solution: a single power equal to a single power base the same, therefore their exponents are equal, solve it. You show me those three green lines, those green starred lines, and you have a perfect looking solution. Let's take a look at problem B. If you're feeling comfortable, remember, give it a pause, give it a go on your own. Otherwise, I'm going to keep moving through. So we take a look at problem B, and I have a power base 2. Where's my variable? It's up in the exponent. Means I got to get out, which means I need a power equal to a power base the same. So I really want to then be able to write 1 over 256 as a power base 2. So I've told you that as long as you know powers base 2 up to powers 2 to the 5th, then you're good. So we know that 2 to the 5th is 32. And what we're slowly going to do then is we're going to work our way above that. So if I double 32, then I get 64. And if I double 64, I get 128. And if I double 128, I got 256. I'm 3 above 5. That tells me then that 256 is 2 to the exponent 8. Make sure that we don't make a key mistake here. Notice that is not a power equal to a power base the same, because that right side is not a single power. It's 1 divided by a power. Only if I write the right side of that equation side as a single power base the same. And now is that useful to me? So notice, maybe I had to bring that power across its fraction line. That meant I had to change the sign of the exponent. I get down to that point. Now I have a power equal to a power base the same. Therefore, my exponents are equal. You have to give me that line. I know that there's going to be a lot of you guys that can see, yeah, but I'm going to have an equation where I'm going to want to put everything on one side of the equal sign. You can't. But once you have that therefore statement, now go as fast as you like. If we recognize that it factors and that we happen to have two different solutions that make that equation true. Just notice it's possible to have a quadratic equation be developed from an exponential equation. We really like the fact that this one factored, but I think you guys can see what might happen. If it doesn't factor, what are you going to have to use? Good old quadratic formula. So take a look at problem C, and really the beginning to problem C shouldn't be an issue. That I'm hoping that through our practice, we've been able to kind of look at some values, and we see that I have a power base 9 equal to 81 times a power base 27. And so we see 9, 81, and 27, and we go, hey, those things are all powers base 3. So we may be motivated then to change each side into a power base 3. I like that as a first line. I just want to draw to your attention the most common mistake you guys are going to make. And what it is you see the right side of that equal sign, and so we want to simplify it. And so I've got my 3 and my 4 times my 3x, 12x, and we're good. I'm hoping that you guys can recognize the mistake on the blue line. Notice that on the right side, I have 3 to the exponent 4 times 3 to the exponent 3x. I am multiplying powers of the same base. Oops. My blue line was incorrect. Let's get rid of it. That really what I should have been dealing with then, my left side equals a power multiplied by a power with the base the same means we add those exponents. There's something in our visual where we see the 4 right next to the 3x, and I don't know if we like kind of see something in here that makes us think like, hey, that's a multiple. Be very careful. I mean, be very careful. Now that we got to that point, we should be pretty quick. I have a power equal to a power. The bases are the same. Yikes. That means that my exponents must be equal. You guys get down to this line, and then I don't care what you show me. Hopefully we're good to come in on that. Okay, take a look at part D, and there's really only one mistake that you guys could make in D. I want everybody to give D a shot. Don't just wait. Everyone give it a try. Okay, now that we're back, the most common mistake right now is to go and do something like this. You guys will notice that what I did is I took my 5 and I multiplied it by my base of 2, and you guys should see why we failed grade 6. There we are, and we just broke BEDMAS. Now, for some of you, you're going to say, I never would make that mistake because I can't write 40 as a power base 10. This is going to be an equation that in 3 lessons' time, we're going to solve that equation. This situation will arise. And so by the end of this unit, you're not going to catch that mistake. So that's what I was talking about segmenting your knowledge. Let's stop. Let's go back to the very beginning, make sure that we don't break BEDMAS, and let's take this one step by step. I've been asked to solve. Where's my variable? It's up in the exponent. That means I have to get it out, which means I need a power equal to a power base the same. Well, right now I have a power 2 to the exponent 3x plus 1 multiplied by 5. Well, if I need single powers, then I want to get rid of that multiply by 5. And I know that if I want to multiply by 5, then the opposite would be to divide by 5. I'm going to divide that 5 out and come in on my 8. I would not have to see that line, because if there's a little bit of forethought with a little bit of experience, you're already going to be looking for a power base 2, if possible. And so rewrite that 8 as 2 cubed right away. Now you have a power equal to a power base the same, therefore the exponents are equal, and I don't even care what you show me next. Jump straight to x equals 2/3 and you are good. You never have to show me the line that I'm crossing out. Don't need to see it. Okay, we're going to jump into 2 of the more difficult problems. And these will be ones that'll be new to you. As we kind of work our way through previous problems, these ones will not have been problems, or may not, I should say, have seen in grade 11. The first one I want you to focus in on is E, because E is going to cause a wrinkle. Now, as you're taking a look at E, I'm going to scroll back up to see all the solutions, just so we can talk about them. When you take a look at all the other problems I gave you, you may notice a key difference between this one and problem E. I'm going to shrink this down pretty good. I want you to notice that the only operations that we've seen in that problem are all multiplication. And now that you get down to problem E, you notice you have addition and subtraction in there as well. And so when we talk about having one strategy to try to solve all of these problems, we're going to talk our way through E. Okay. I've been asked to solve. Where's my variable? It's up in the exponent. I've got to get it out. Okay, what operations do I have in this equation? I have add or subtract, and I need it to be multiply. Well, I know how to get rid of add and subtract in an expression and change it into multiply. That means factor. So I'm just going to make a little note up top that my add or subtract drives me to the instinct to factor. I'm going to take a look at this and say, I can see how I can factor that expression also. Maybe you can see it. Maybe it's a struggle. But if I rewrote my equation in that form, some of you might see it now. Can we see the quadratic? Can we see our simple trinomial? Perhaps we're still struggling to see it. And if we are, then I'm going to go through and use a little substitution. I'm going to let A, something else, equal that expression that I see pop up in multiple places. And so if I replace my 2 to the x with an A, now that has to scream at you to say, hey, there's my simple trinomial. You guys can see that for us to be able to factor that, we would then say, hey, 2 numbers that multiply to give 32, and add to give negative 33 is a negative 32 and 1. And therefore, you could work your way down and you could then solve and say, hey, so A equals 32 or 1. Here's the problem, though. I never gave you a problem that contained A's. You need to solve for X. So now we would have to go back and resubstitute, and therefore 2 to the X equals, well, that seems like a pain. Can we just get rid of all of that blue and say that if we can now recognize that that is part of our solution, that really what I had was this common expression of 2 to the x that was hidden in there. Well, if we can recognize that then as a simple trinomial right now, why not just factor it as written? Two numbers that multiply to give 32 and add to give 33 is negative 32 and negative 1. And what was it that was squared? What was it that was the single something? 2 to the x. That if we come in on this line, you guys can then jump to this as a next line. Sorry, I got a little ahead of myself there. And now you notice that we have the easiest of easy exponential equations. For me to solve each of those two equations, where's my variable? It's up in the exponent. I got to get it out, which means I need to get a power equal to a power, base the same. Now that I do, therefore the exponents are equal. Now, this next one might look a little tougher. Like it almost might even feel like a trick to you in a way. But you should love it when you have a single power equal to 1, because I can write 1 as a power of any base by putting the exponent 0 on it. And therefore, x equals 0. So notice that problem E was really a hidden quadratic. What drove me to that instinct? My variable was in the exponent. I had to get it out, but because I had add or subtract in my equation, I needed to factor to get back in my multiply. You guys take a look at problem F. You'll notice we encounter a similar thing. For me to solve that, where's my variable? It's up in the exponent. I got to get it out. And I notice that I have subtraction. I also want you to notice, though, that problem F is different than problem E. Where I extend my knowledge, my strategies, is that my decision to factor F isn't a quadratic. What caused me to factor E as a quadratic? Because I had multiply in my exponent. What causes me to factor F differently? Because I had add or subtract in my exponent. That if I can't factor that as a simple trinomial, then maybe I can common factor with those two terms. And so between those two terms, I notice that there's at least a 2 to the x in both. I have to work backwards a little bit now. What would I multiply 2 to the x by to get back me to 2 to the x plus 2? Well, I got to change the exponent. That means I need a power the same base. If I'm going to multiply those powers, that means I'm going to add my exponents. And I can now see that if I was to expand that, 2 to the x times 2 squared gives me 2 to the exponent x plus 2. Now I can work to get my second term. What would I multiply 2 to the x by to get me back to 2 to the x? And that's equal to my 48. Notice I just cured my problem. Look inside my brackets. I don't have any variables in there. And if I don't have variables, that means I can calculate. And now, by me getting to this, I create an equation that looks an awful lot like equation D. Where's my variable? It's up in the exponent. I got to get it out, which means I need a power equal to a power base the same. That means I've got to get rid of that times by 3. So the way I can get rid of a times by 3 is to divide by 3. With a little bit of forethought, we may have jumped to that line, and therefore we're coming in. Now, I went through that stuff pretty quick for you guys. Most of that should have been a review. The only thing that wasn't a review was E and F, potentially. But as you take a look over those examples, those should help you guys with some practice. I'm going to throw up one more screen that has 4 problems on it. I want you to take a look at these 4 problems because they're kind of jumbled in a way. If I pull those problems up. And now, I want you guys to try those problems. Give them a shot and see how they go. I won't ask you to pause the video because I'm not going to put up full solutions of these. I'm going to post full solutions of these to our classroom. So I want you to give these 4 a shot, see how they go, and hopefully everything goes well. Good luck on your practice, guys. Take care of yourselves.